Yo, what's good, guys? Welcome back to another video. Shout out GitHub followers. I appreciate y'all. Um, I can't believe how we're at 104. 104 people. Y'all really clicked on the link and clicked the follow button. Thank you. So we got Pokemon of the day. That Pokemon is Golbat. We got to make the Pokemon sound of the day. Let's take a listen, shall we? Golbat. Golbat. Okay. Leetcode of the day. Let's get into that. Let's get problem of the day. Hopefully it's not a hard one. Another easy problem, what? I've literally solved this problem before. I'll also just solve it again. No big deal. Okay, while okay, I equals 0. So the way I'm going to do this, guys, is I'm going to start with some pre-structuring, pre-computations. So it's going to be pretty simple, right? This is our input string. Return true if and only if s can become goal. Okay. So we're going to loop through s until we get to the first wait. Does that even work? What I was going to say is we can just loop through s until we get to the first letter of this one, right? So we get to, like, we loop through, oh, here we go. Okay, so I equals 2, right? Because 0, 1, 2. And then we can start looping through, like, them at the same time. So it's like D right here. And then we get to E, right? And then S needs to go back to the start, right? And then B. And then obviously you get to the end of goal and you've completed all the characters and they were all matching. The problem is it's like if goal had multiple of the same character, this could cause problems. Like, let's say there was a C right here. Yeah, there was a C right here. And a C right here, right? Those are still matching. But I would start with this C. I would be like C and then B, and then it would just be wrong. So the only other way I can think of doing it is if I just like is there a way to make it like circular? Because I feel like that's how I solved it before, and it was not a very good solution. Now that I'm thinking about it, I think the way I said it passes though. Like if you just do it multiple, like if you just store all the occurrences of the first letter. Can I just rotate it at like n times? Is that cool? Is that allowed? No. Like, can I do like, man, I feel like I'm overcomplicating it. But also, I don't like the solution I described. I don't like doing it like that. That feels kind of... But it would be faster, though. All right, so we're going to make... Now I'm just going to do it the way I said it originally. So we're going to do SP, which is just like starting points in S, according to the first char of goal, right? So like the first char, oh my god, of goal is goal at spot 0, right? I don't know why I'm deciding to make it hyper readable like this, even though I don't even know if this is right. So for C in S, if C is equal to the first char of goal, then we're gonna append I. Oh fuck. We're gonna need to append the starting point. Man, it just doesn't make sense to do it like this. Can I do 4? Nah, whatever. Hold on. Just if they're, if they're not matching length, obviously you can't rotate it to make it equal. All right. That append I. Right. Okay, great. So now we got that. Now we need to while SP, right? Starting point. So we're gonna get the starting point. So I or J equals sp.pop. We're just gonna get the last one. It doesn't matter that it's like a stack here. It's just whatever. We're gonna do 4i in range, 0 to the length of goal, right? If S at spot J doesn't equal goal at spot I, return false, right? And then at the end, we need to increment J plus equals 1. And then we need to reset it to 0 in case it's out of bounds, right? So if J is equal to the length of S, J is going to be equal to 0. And I was a big fan of like same line if statements, and I don't know anymore. No, you don't return false though. You just break. I mean, you return break. Hilarious. I mean, I could do a flag here. Yeah, I guess I'll just do like matched equals true. And then if this happens, then matched equals false. And it's like if matched, return true. This feels like overly complicated. Let's just see what happens. Oh, no. Let's see if that works. I mean, the first one returns true, so I don't know. Okay, nice. What was my submission before? What do you guys think? September 25th? That was like over a month ago. Let's see what I beat 6.3. But it's bugged now. I can't even see if I improved or not, right? Like if I go to submissions, it just says 0 MS. Like, okay. Dope. Let's compare them. Let's see what I did here. I literally did the same thing. Except for some reason I did this in 2 lines. I don't know why I did that in 2 lines. Oh, I guess I could have done it like this. I mean, I literally did the exact same thing I did before. Possible starts. Look at that. Is that the best way to do it? O of n, list most common string. 1 line. I don't want it 1 line. Return goal. Okay. Okay, I guess that's facts. Wait, this is an interesting way to go about it, actually. Yeah, I mean, this makes sense that would work like that. That's probably faster than what I did. Isn't this a 1-liner? Like, can't I just do like return? All right, if len of doesn't equal. And then it's return goal in s plus s. Okay. Wow. Awesome, bro. That's really dope and chill how that works like that. Okay. Pretty easy though. Let's see what we got in the comments before we move on. I love checking the comments. Okay. Leetcode fix extension. Wow, that was seamless. Isn't that crazy how Chrome extensions are so seamless like that? Like that just took me like less than 5 seconds to install. Now I can see dislikes. Cool. Oh, you have 11 problems solved, dog. You bro, I'm telling you, this types of people like who are like, this guy's how to use Leetcode effectively. Bro, you have 11 problems. You aren't even using Leetcode. How are you gonna try to use it effectively when you aren't even like types of questions you need to ask like after like 100+ questions, you know, in my opinion. Let's do some Leetcode problems. Leetcode IO-Pro. roadmap. Now I did this problem, but like, I mean, oh damn, I really just finished one DP. What's going on here, bro? Why are all these questions hard? What's going on with that? I don't even, man, that problem's freaking hard, dude. Whenever you see this problem, bro, you just know it's 2D DP. Just how it works, bro. Okay, oh, I've done this problem before. Let's just do it again. Right, so this is pretty simple. I just remember how to do this problem. It's like there's only one way to reach here, 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 and here. This problem's actually really simple, so we'll just draw it out real quick. How many? There's 1, 2, 3, 4, 5, 6. There's 6 lines. So 1, 2, 3, 4, 5, 6 lines. Okay. So basically, guys, check this out, right? You guys are following. I know a lot of people follow along with the Leetcode. Okay. So you should be able to explain problems like this. Okay. And I'm not gonna lie, I know this problem like very intimately. So I'm not sure this is like the best example, but anyway, basically, guys, I'm just gonna assume you guys have read the problem description because I don't want to go over it. But basically, guys, so the robot starts up here, right? So I mean, it makes sense, by the way. Like the robot can only move this way and can only move this way, right? And since it starts here, there's like literally only one way to get to this square, okay? And if the robot is only able to move to the right and down, like how many ways can they get to this square if they can only move to the right and down? One way, right? Because like, you know, if you go down here as your first move, you can never get up here, right? And if you go here, obviously you're here. You can never come back to the same square. So with that same logic, it's going to be, there's only one way to get to all of these squares. And with the inverse of, since you're moving to the right this way, and it's, if you understand why you can only get to this places once, then it makes sense why you can only get to these squares once as well. Because it's following the same logic. Like if I decide to get to this square, the only way to do it is down, right? Like I can't go to the right, down, and to the left. This left maneuver is illegal. So there's only one way to get here, and then by extension, there's only one way to get here. Now the tricky part is in these middle squares, right? Like what am I doing in these middle squares? So basically, guys, think about how many ways to get here, right? Don't even worry about these ones for now. Just think about it. Like if you can only move to the right and down, okay, this is one way. This is one way, right? 2. And what do we notice about this 2 is that it's just this number plus this number. I think that pattern becomes a little bit more obvious as you kind of go forward. But like, for example, this square, right? So how can I get to this square? I can get to this square like this. I can get to this square like this. I can get to this square like this. There's literally no other way to get to this square besides these 3 options. So check this out, right? It's just this square plus this square. And if you continue this pattern, you know, you'll get this, you know, this is your like X marks the spot. You're trying to get to this spot right here. If you just continue to follow the pattern, what is this, 28? 28. Output equals 28. Look at that. So let's code it up, shall we? Not gonna lie, guys, that talking just took a lot out of me. Jesus. Imagine I explain that on an interview, bro. You just give me the job right there. All right, so we're just gonna initialize the top row and the first column to 1. Okay, pretty simple. Oh, we need to create the board. How does it 4? How do you do this? I don't know the syntax, bro. I don't think that's right. Yeah. Is it like multiplied here again or something? Oh my god, dude. What's the syntax, dude? Okay, I'm cheating. I'm stealing the syntax. I'm only stealing this first line. I was close. You just need to surround it with brackets. Yeah, nice. Look at that. Okay. So n is this top one. So it doesn't matter. It's 0 to I equals 1, and then 4I in range. Maybe we'll do J. We'll also what is this? When you forget how to code? Jesus. Maybe these letters are a little bit misleading. Let's just make sure we did that right. I don't really want to change. I don't care. Nice. Okay. So 4I in range of 1 to n. 4J in range 1 to m. dp at spot I spot j is equal to dp at spot I minus 1 j plus dp at spot I j minus 1. Return dp at spot -1, -1. Man, come on, man. Really? I mean, I'm just gonna like, okay, let me just try switching these around. Chill, chill, chill. There you go. That's impossible to think about, bro. It's like not my fault. Okay. I mean, this is like the easiest problem ever, so. All right, longest common subsequence. All right, I've never done this one, so this one's probably gonna be a little bit more tricky. By tricky, I mean it's gonna be impossible. Their longest common subsequence. If there is no common subsequence, return 0. A subsequence of a string is a string generator from the original string with some characters. Man, okay. Think about how I want to do this one. So I have an idea on how I want to do this one just by looking at it. Because this reminds me, the word subsequence reminds me of LIS, which is longest increasing subsequence, which is like just like a genius algorithm that I would have never come up with myself, basically, on some nerd shit. And what I want to do here, I think, guys, check this out. So I'm going to take the longer string. In this case, it's ABCD, right? And I'm going to create this DP array. And every single DP array, or it's going to be, the length of this DP array is going to be, text one, right? But every single index is going to have a set. It's not going to have like, yo guys, last week I averaged 2 hours on my phone every day. Just want to let y'all know. I'm trying to fucking do not disturb, dude. I'm working. I'm actually working right now. So it's going to be a set on each indice, right? So that in this case, there's going to be 1, 2, 3, 4, 5 sets. So this set is going to contain all, every single character at that indice plus the next ones, right? So this one's going to have, I don't know if that makes sense, A, B, C, D, E, right? Like individual characters. Because at the first index, right, index 0, that index, it's going to have all the characters that at that spot and after it. I think those make more sense. Like the last set, for example, will have only E, because that's the character you have right here and after, right? And obviously there's nothing after the last one. But this one has the A, right? And then all of these after ones. And why that's going to be helpful, guys, is because basically as we look at, we're going to loop through we're going to go through iterate this one. Oh my god. We're going to iterate through this with this text too, okay? So like for example, ace, right? We're going to look at the first character here, ace. And is that going to help? We're going to look at the first character, A. Hold on. We're going to look at the first character, A, here. And then after we look at A, we know it's 1 for a fact. We know it's 1. So we can update to 1. And what if it's CE though? What if it's ACE? Then the answer is 2. But how would we know that? Do we start from the back? Like we start from here. And then we go here. Like we see this E. Right, so it's 1. And now we're looking for a C to be added. Well, why would we need a set? Fuck. Me when I get confused. Dang it, dude. I really thought this was going to work, man. Okay. Yo, why can't I just delete all the characters that are not in ace, right? So like I have two arrays, right? So I start with like, so I make this a hash map so I can easy access. So then it's B, right? Like B's not in there, so I just chop it off. D's not in there, so I chop it off. And then I just go like in order. Do I go in order? Doesn't matter. What if the first one's not in there? So it's like C. It's a C. Well, then I'll just chop off the A. No, that wouldn't work either, because then what if it's like a bajillion letters long instead? God dang it, dude. I'm gonna go to the bathroom. Be right back. All right, I'm back. Dude, the problem is you just don't know the order. Like, you know? Like at each set, would I... Shoot, dude. I feel like it's with the set, though. Like, all right. Give me like 15 more minutes on this problem, then I'll look at the solution probably. Maybe even 10, dude. I just... It's like you would do the set thing, but you would go through all the characters. So you would check, is A here? Is C here? And is E here? Oh, they all would be here. So what does that mean? Oh, you gotta check like if there is an... Oh, I think you start from the back or something. Like you start from this back one and you loop through this. Like, is there an A there? Is there a C there? Is there an E there? But like, I don't know what the... Okay, there is, right? So we start... There is an E there, so what do you do? So like, wait, that's one now? But it's not ordered. Like, how would I... Like, let's say this was a C. Okay? So we know the answer is 2 in this case if there's a C. Instead of this E, right? So how would I go through that? So this is a C. So no, or no, yes. Wait, that works because then you just cut off this E or some shit. No, that's stupid. That doesn't make sense. Hold on. No, I feel like I'm close, but... Okay, I start with this A. No, wait, yeah, no, this works. If I have the set thing that I had before, then I know I can only look at these after. because it's ordered. Hold on. Okay, let's just do this. No, I think this is gonna work, guys. Like, I'm not even joking me. But how would I even like? Would I just do it backwards? What if it's multiple then? Would I do a dictionary if it's multiple then? Man, this is tough, guys. I think that's how you would do it. All right, so for I in range of len of text one, or whatever, which one is greater, like lengthwise. I mean, maybe it just doesn't work then. Probably just doesn't matter. Okay, we'll figure that out later. -1, -1, -1. Okay, we got dict character count or something like that. I don't know. Whatever, it doesn't matter. So C equals text 1 at spot I, right? If C not in C, and then you just like make this like long ass name, and it's just like, wow. At spot C equals 1, else the same thing, but then you're just gonna increment it. There's a one-liner way to do this, but I still refuse to learn it. Okay. And then at the end of this, we're going to dp at spot I dot append. We need a copy of it. Make this dict dot copy. Does this make a deep copy? I need a deep copy. Okay, I'm just gonna try this dict dot copy. I'm gonna try that. Let's see what that does, guys. Whoops, you're right. Okay, so look, we got E, D, so like E1. No, that's right. Right, okay, that's right. So then it's 4. Here, let's just do this like text to R. Right, okay, so What's the percentage rate on this one? 50. That's pretty high, bro. I'm not gonna lie. Basically, we want to loop from the start. So for C in text2. The reason I made it an array, I guess it doesn't even matter. I could have just, all right, this doesn't matter. Yeah, I'm just going to delete that. For C in text2. No, but I need an I though. For I in range 0 to len of text2. C equals text2 at spot I. Because I need to chop it off after I. And I need to do this multiple times. Is it's for in DP. I'd rather not use that word, but dict is also a keyword, which is kind of bothersome. I'll just do 4D for dictionary for now, because I feel like I'm going to be writing it a lot. Maybe we can spruce it up after, but basically, if C in DP, or in D, right? So in the dictionary, we're going to have a little bit of a counter variable, right? So then C, so D at spot C minus equals 1. If D at spot C, oh my God, equals 0, then we're going to del D spot C. Oh, but for the rest of them, though. That creates a problem because it's for the rest of them. Shoot. God dang it. I ran into another problem. Is that going to be a problem? Yeah. Yeah, it will be. Frick, dude. No, that does create a problem, guys, because like the problem is that like let's say there's two C's here, right? Let's say there's, okay, well, it doesn't really matter for this one. Like let's say there was a C right here, right? No, wait. What would be the problem? Yeah, because there's a C right here, right? So we're going to do this. We're going to chop it off. We're going to have CE. Right here, we're going to C. Let's say this was ACCE. Okay? And we check right here. There's a C from this point on. So we're going to add one to the counter. But then when we get to this next C, there's like, there shouldn't be any C's here, but there is. Does that make sense? So I have to delete all of them. But that's just like that's just like really annoying. for I in range if I mean, that's the only way I could do it. But I'm like, look, I'm nested 1, 2, 3, 4, 5, 6, 7 nests. That's how you know I'm doing it fucking wrong, bro. Look, I, J, J, fucking K, bro. Like, oh my god. Spot J. And it's from I to len of DP. And it's going to be text2 equals text2 J to the end. Which includes it. So it should be J plus 1. That might give me an error break. This might give me an error. If this gives me an error though, I think I'm doing it right. Oh, shut up. Oh. This is not just TLE though. Like, I don't really get it. Okay. Output 3 expected. So we're gonna do this. Yes. No. EZUPKR. No. No. Should have ended right there. P right here. Yeah. But it might not be. Because what's the optimal? It's 1. Oh, these are not ordered. That's the problem. That's why you got to go from the back, dude. Because you start here. You just know it has to be R. Right? And then you check for M. Check for B. Check for U. And you see there's a U in there. Yeah, you gotta go from the back, dude. There's no way you go from the front. There's no way. Like this one, you start from the back. E and E match. Okay, great. So now you have ace or AC. No. Yes. So now you delete whatever is the... You chop off from here to here. But that's not DP. That's just brute force. Like if I go from like 4, okay. So a counter equals 0, 4 I in range, len of text 1, minus 1, minus 1, minus 1. Then it's 4j len of text 2, minus 1, minus 1, minus 1. So like if C2 is equal to C1, then text 2 is equal to text 2, but then it's like chopped off to J. And then you break. And then the counter gets updated. And then you just return counter. And then why, like this is, no, 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 yes. Oh, and then that's why it doesn't freaking work, bro. And then I just stop it right there. And you get this R right here. And you got this Q right here. We do like a max or like res equals 0. And then if oh my god, this problem's so freaking hard, dude. I'm gonna cry because of how hard it is. That's the thing, guys. I'm literally crying right now. That's the thing, though, guys, that I'm crying. Because that's the DP part, is you're supposed to like keep track of both somehow. Pi, Y, R, Q, bro. Like, Jesus Christ. Is it all the numbers before it? Like, let's say I have, right? So then in this case, I would have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So I would have 11. So it'd be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, right? And I would go through here and I would get to this S. I would put a 1 here. Okay, because it's all of these added up plus the 1 here. Okay, and then I'd get to this R. Wait. So 0, 1, 2, 3. 0, 1, 2, 3. And I'd put a 1 here. Right, I would add all these up and then a 1 here, plus 1. And then I would get to R, Q, right? Q's in there, so I would add, so this would be 2, because it's plus. And then yeah, no, this is definitely how you do it, dog. I'm not even joking. I'm not even joking. This is how you do it. Okay. So then it's so it's like it's cur freaking like so we'll just do cur equals plus equals. So cur is 0. The start of this, and that's cur plus equals dp at spot j, right? Most of them are going to be 0, so that's chill. We're just never going to shrink it down though. dp at spot j is equal to 1 plus cur. We're just going to break right there. Return max of dp. Does that work the way I think it does? We're never using this counter variable then. And we're never using res either. Just get rid of those, I guess. But then that's one-dimensional dynamic programming. This is not two-dimensional. And it's just wrong. This should not be returning 4, by the way. Ah. Yeah, that would make sense why it's returning 4. Cur. Is it equals max of cur and dp at spot j? Is that the algorithm there? Yeah. I believe it is. Nope. Oh my God, dude. Man, this is so tough, dude. The moment when you're never gonna make it. Okay, no V, no K, no J, no K, 1B, B right here. How am I getting 2? Oh, because it's this M. Yeah, that doesn't work. Wait, what? It should still be 1 though. Because when I get to this M, I get to here and it's just 0. Cur is 0, so it's 1 plus, and then I break. Wait, what? This should still be right though. I don't understand why it's how that would be working. Oh, that's how. Yeah. Man, these duplicates are murdering me. B. I don't get it though. It should only have been once though. Oh no. Yeah. I don't think I can delete it either. I don't know. I give up. I have given up, guys. This problem's impossible. What is the freaking like discussion on this? Because this problem is so hard. Or is it easy and I'm dumb? Encountering D problem makes me feel useless, please. What? Bro, maybe for you. For me, I'm looking at this and I have no goddamn idea what's going on. dpij equals dp at spot I minus 1, j minus 1, if text at spot I is equal to text. Otherwise what, though? No, I don't get it.
Hey everyone.
18 minutes. Let's go.
Hey everyone, welcome back and let's write some more neat code today. So today let's solve longest common subsequence, a dynamic programming problem. And this is pretty much one of the most popular dynamic programming problems. So we are given two strings, text1 and text2, and we just want to return the length of the longest common subsequence between these two strings. And you might remember from my last video where we learned basically what a subsequence is. It's basically you take a string, right, like this string A, B, C, D, E, and you just, you choose a few characters from it, while you maintain the order. So one subsequence from this string could be A, B, right? You take the first two characters from it. You can take any characters. You can choose to remove any characters. You can do whatever you want. And so we're looking for the longest common subsequence. So a subsequence that is in both of the strings. So in this example, we have two strings, right? A, B, C, D, E, and A, C, E. So what is the longest common subsequence between these? Well, when you take a look at the first string, you see that, hey, they both have an A, right? They both have an A in the first spot, so that's good. So now let's look at the second character, B and C. Well, this has a B, but the second string does not have a B. But the second string does have a C, and we also have a C over here. But the second string does not have a D, right? So we can't include the D from the first string, but then we see the last character is an E, the last character in the other string is also an E. So we get the longest common subsequence to just be the original second string, right? Ace, because ace can be found in the first string. All we have to do is remove a couple characters, right? Remove the B and remove the D, then we get a subsequence that matches the second string. So the length of the longest common subsequence is 3. So how can we solve this problem? Well, as I mentioned, dynamic programming is the most efficient way to solve this problem. But before we even get into the dynamic programming solution, which is going to be a two-dimensional dynamic programming solution, before we get into that, let's just notice one thing. So let's say these are our two strings, right? String 1 and string 2. Does it at least make sense to you that, okay, like we would want to start, let's say, at the beginning of both strings, right? Like we're looking for the longest common subsequence. It might just be that both of the strings are actually equal, right? That could be a possible way. So let's look at the first character in each string. And in this case, they match each other, right? They're the same character. So does it at least make sense to you that if both of the characters match each other, right, the first characters, that the longest common subsequence, then we can break it into a sub-problem, right? Now, the new problem we're looking at is finding the longest common subsequence between the remainder of both strings, right? Plus 1, because we see that the first two characters are equal, right? That's where our 1 comes from, right? Because we know that the longest common subsequence is at least going to be 1 because we found a matching pair of characters, right? And then we have a sub-problem, right? And you might know that that's what dynamic programming is all about, finding the sub-problem. Now, what if this character was a B, right? And this is an A, so clearly they're not the same character. What would we do then? Well, we can't do what we just did. We can't add 1 and then find the longest common subsequence between the remainder of the two strings. We can't do that. But we can break it into a different subproblem. We can say, well, it's possible that the longest common subsequence could be between these two strings, right? Or it could be between this string and this string. So this is just a little bit of an explanation before I show you the actual dynamic programming solution, right? Basically, what we found out is that based on comparing the first two characters, whether they're equal or not equal, we can break up the problem into sub-problems and then solve those sub-problems. So take a look what I just did. I took the two input strings, right? String 1 and string 2, and I wrote them in a different way, right? I said that this is a two-dimensional dynamic programming problem, and you might know that a grid, a 2D grid like this, is commonly used to solve these types of dynamic programming problems. So notice that for each character in both strings, there's a square, right? A position, a cell that we can put a value in. We're going to put a value in each of these cells. And so let's just start at the beginning like we did, right? So let's start at the first characters, right? What we're trying to do is, for these strings, find the longest common subsequence between the entire strings, right? So what we're going to do is put that value right here. That's what's going to be the entire longest common subsequence. So we want to compute the value that goes here, but what you're going to find is, to do that, we need to solve some sub-problems and then, continue to do that and then work our way back up to this position.
Mm-mm.
So
That
what
don't
do
make
we
sense.
notice? let's look at these two characters, right? They're equal, A and A, right? So, okay, so now we want to find the value that goes here. How can we find that value? Well, like I mentioned, right now we're trying to solve a subproblem. We want to find the longest common subsequence between these two substrings, right? We don't have to check these A's anymore because we know they match each other. So now I want to find this new subproblem, right? And so basically what I'm saying is I'm going to go here. I want to solve the subproblem that goes here. So now we're here, right? We're comparing this B with this C. We see that they're not equal this time, right? That means we're not going to be going diagonally. We're not going to look at this subproblem. We're going to look at a different subproblem. Since these characters do not equal each other, we have to check two different subproblems. It means that the longest common subsequence between these two substrings is going to be found in either of these two positions, right? So let's look at this position first. What this position tells us, we're trying to find the longest common subsequence between this string and this string, right? So basically we're not looking at this C anymore, right? And this position tells us that we're looking at the longest common subsequence between this string and this string. So basically when we remove this B, right? And just by looking at it, right, you can tell that this is going to, these two strings are going to lead to a longest common subsequence of 1. Just by looking at it, right, because you can see that this has one character, it's an E, it only matches this E, so that's going to be a 1. But when you look at this string and this string, right, corresponding to this position, we see that this has a CE, this has a CE, so this is going to end up being a 2. But let me actually solve the rest of it a little bit. So mainly looking at these two strings,
Yo, Loki,
right,
like I get it,
this position,
but this is not, like I half get it.
Match each other, right? So since, remember, when the characters match each other, the first characters of both strings match each other, that's when we go diagonally. And the reason we go diagonally is because then we know we can look at the remainder of
I would have never
the
come up
strings,
with
right?
this.
We know that this C matches this C, so we want to look diagonally. We want to look at these two substrings. So what's the longest common substring between these two? Okay, so what are we going to do? Let's compare the first character, right? So D and E. So these characters are not equal. So remember what we do when the first characters are not equal. Then we can't go diagonally. So what do we decide to do? We go to the right and we go down and we take whatever the max of these two is and then put it in this value. That's what we're gonna do. So first, let's check this right position. So what does this right position even mean? It means we're taking this substring and finding the longest common subsequence with this substring, but this is an empty string. So what's gonna be in this cell? Remember, this is actually out of bounds anyway, right? So what default value are we gonna give ourselves if we go out of bounds
0?
to the right? Clearly, the longest common subsequence between a string and an empty string like this is going to be 0, right? So really, what we're going to initialize is we're going to say every value in this column is going to be 0. Similarly, this is an empty substring. If we were trying to find the LCS, the longest common subsequence between this and an empty substring, we would also get 0. So what we're going to do is put a 0 in these positions, right? That's just how we're going to initialize our 2D matrix when we start the problem. Okay, so remember what we were doing. We were at this position, we were going right and we were going down trying to find the maximum value. Well, clearly to the right we get a 0, so that's not the max. So let's go down. Okay, now we're down. So what are we doing? We're finding the LCS between this substring and this substring. Well, they're the exact same, right? E matches E. Okay, great. And remember, when characters match each other, that's when we look diagonally, right? So we came down here and now we're looking diagonally. Clearly, we get a 0 here, right? So 0 plus 1. The reason we're doing a plus 1 here is because we found matching characters. When characters match, we add 1 because clearly the LCS between these is going to at least be 1, right? At least one of these characters matches. So now I'm basically going to go here and then take us back along the path that we came from and then show you what the solution is. So we had a 1 here, right? And so from this position, we went down. So since we were going down, that means that this character and this character did not match each other. So what we're going to do is just take the 1 and put it up here, right? So there's going to be a 1 here because the LCS between these two is 1. But now we're going to go back over here diagonally, right? Diagonally means that this character matched this character, right? So we're going to take the value that we got up here, put it over here, and add 1, because remember, these match each other. So we're adding 1. That means we're going to end up putting a 2 in this position. And now we're going up, right? We're going up because that's where we came from. And remember, when you go up, that means the characters did not match each other. The C and the B don't match each other. So we're going to put a 2 here, right? We're just taking this 2 and putting it over here. And lastly, we're going back here. That's where we came from, right? Diagonally. That means the characters were matching each other. So we can add at least 1 character. So 2 plus 1, that's going to be 3. This is how we got the result, right? So we got a 3, meaning that the LCS between these two strings is 3, right? And that's what we learned from the problem explanation. So, right, what we're going to do is return 3. That's our result. But you can see that the way I did it was basically intuitive, right? I used this picture and basically solved this problem by hand using a little intuition and stuff, right? But the way we're going to have to solve this with code is going to be brute force-ish, right? So it's dynamic programming, but what we're going to have to do is for every value in this cell, right? So we are going to initialize these zeros, right? But with this matrix, right, this 2D matrix, we want the value that goes up here, right? And to do that, we have to compute the value that goes here, that goes here, that goes here, and basically for all these, and then finally we'll be able to have the value that goes here, which is the result that we're going to return. And so basically what I'm saying is this is going to be a bottom-up dynamic programming solution, right? Bottom up, meaning we're going to solve it in reverse order. We're going to first get every value. We're going to get the value that goes here and then work our way up until we get to the result. And you might have noticed, see, I have an I that tells us the column. I have a J that tells us, actually the column, and the I tells us what the row is. And so when we're working our way, starting at the bottom and then working our way up, how are we going to determine what value goes in each cell? Basically what I went over earlier, right? So we're going to look at the characters, and if they match each other, what we're going to do is say 1 plus the value that's diagonal, right? And we know when we go out of bounds, there's a 0, right? There's an implicit 0 when we go out of bounds. And we're going to do that with every single cell, right? So when you look at these two, we get an E and a C, right? And when characters don't match each other, right, that's important. What we're going to do is we're going to look down, right? We see a 0 down here, and we're going to go right to the right side, and we see a 1 here on the right side. And what we're going to do is take the max of those two values, and we see that the max is, of course, 1, right? 1 is bigger than 0, and then we're going to put that max value in the cell. So that's really it. There are two choices, right? If the characters don't match each other, right, in this case, or if the characters do match each other in this case, right? That's basically how we're going to solve this problem. It'll make a little more sense when I show you the code. So remember,
Nah,
we're going to
bro,
have
guys,
a 2D
I don't get
grid.
it. Like, I get it, what he's doing. But, like, Jesus Christ. Like, I would have never figured this out. And I still, after watching this video, I still don't think I could code this up.
Sense when I show you the code. So remember, we're going to have a 2D grid. So I'm going to call that DP for dynamic programming. It's going to be a 2D grid. And what I'm initially going to do is set it to all zeros, right? So, and I'm just going to do a little bit of Python stuff. So list comprehension in Python. So we're going to go through every single value in the length of text 2 plus 1, right? Plus 1 because we know that we need at least one more column to have all the zeros in it. And so remember, we're going to put a 0 for every value in that. So length plus 1. And we're going to have this row for every value in the length of string 1. So text 1 plus 1 as well, right? So we're basically, if you're not familiar with
Yo, this isn't a real problem, by the way. I'm just gonna tell you right now, this isn't a real problem. 1, 2, 3, 4, 5, 6. That should be 4 shits. Yep. Okay.
Python, this looks complicated, but basically we're getting a 2D grid of dimensions length 2 plus 1 times a length string 1 plus 1.
Top 10 most impossible
initializing
problems of all time, or what?
Zeros. And then we're just going to have a nested loop. And what we're going to do is iterate through this 2D grid in reverse order.
Like that? Oh, len of dp at spot 0.
So in Python, you can do it like this. And basically what I'm doing is...
Oh, right. Right. They should probably be like this then.
Starting at the bottom right of the matrix and then working our way up. So this is how you do it in Python, -1, -1. And let's do the same thing for text 2. And so remember, so we're going through every cell in our 2D grid. And remember, there were 2 conditions. One condition is if the characters in both strings match each other. So if text 1 of I.
Okay, if text 1 at spot I is equal to text 2 at spot j, then dp at spot ij is equal to 1 plus dp at spot I plus 1, j plus 1. If else dp at spot ij is equal to the max of dp at spot I minus 1 j, and dp it's plus 1, dp at spot I j plus 1, and return dp at spot 0. It's so elegant. It's so elegant. Oh my god, it's just the worst. It's just the most elegant algorithm of all time.
We're going to do math because the diagonal.
Oh, one. Did I even add the 1? Yeah, I did.
And remember, we're adding 1 to it because these characters match. That means we add a 1. And if they don't match, that's the else case, right? So we're doing something different here. We're going to put a different value for dp of ij. And in this case, what we're doing is we're finding the max values to, but values to of that max. So all the time complexity of this is the length of the strings multiplied by each other. So if the length of string 1 was n and the length of string 2 was m, we just multiply them together. So this would be the time complexity. That's also the memory complexity because we need extra memory for our 2D dynamic programming grid.
What a problem, bro.
Oops, I had just one little bug. I added 1 to the inside
Unreal.
of that function, but I needed to add 1 here. But other than that, you can see that the code does work, and it is pretty efficient because the dynamic programming solution is the most efficient for this problem. So I hope that this was helpful. If it was, please like and subscribe. It supports the channel a lot, and I'll hopefully see you pretty soon.
Yeah. Alright, time for me to take a break. I'm done with Leetcode for the day, though. Alright, guys, I'm back from my shower. Let's do some project work, shall we? So last time we actually fixed some stuff. No, I don't know what that does. Oh my god. Basically, we got this, right? We got the song search. We got the playlist. And now we can make a playlist, right? So like new playlist. And it automatically goes to this playlist. Then we can just add shit to it. This success box shouldn't even be here. Oh, and I got copyright banned, striked. I gotta mute the video. The fuck? Okay. That's fun. Okay. Okay, so I need a way to delete songs off playlists. How do I do that? I want to be able to left click and then delete. I think is the best way to go about that. Okay, nice. Now we need to do something else. No, maybe we want to change the name later. I don't know. On a label, where's the label at? Can this be on left? Yeah, that's just not what I asked though. Is primary button down? That's what I have. That's what I have though. Hmm. Okay, we got that working. Else if e dot.
The list of paste, and I'm gonna make one. Alright, so the first thing I'm going to create is the layout, the stack pane layout. I'm going to use object here, and I'm gonna stage that set title. This will be JavaFX context menu.
What is a context menu? Whoa. Yeah, that's what I want right there. How do I like use it? Stage.show. Wait, what do I add it to though? Well, this is alert.show and wait. That's not what I want, I think. Um, I have the scene and I don't know what to add it to. Stage that set scene SC. A window? What is a window event? I don't know how to do this, guys. I'm really just stuck on how to add the right click to the... Like, I don't have a stage object anywhere. Stage? I just don't understand how JavaFX works is the problem. Okay. How do I detect a click? I see. Remove song. Okay, so we're gonna need to copy this right here. Nice. Okay. Okay, if I'm lucky hungry. With ease, bro. With ease. Okay. Now we gotta find a way to delete playlists. Which should just be a button right here. It's probably in the playlist catalog, no? Playlist choice, new playlist, yeah. What is this? A private button. I'll just delete this, by the way. Get layout. What do we need to do? We need to add a button. So I guess private button. Is it handle make playlist? Okay, so private void handle delete playlist. Okay. I want another context menu, to be honest with you. I like the context menu a lot. How do you, and what did I do in here? It was, where? No? We'll just call it context menu, honestly. Oh, I need to get the playlist that I clicked on. How do I do that? Do I get it from the combo box or? I need to use this function. Delete playlist in catalog. Is it the... Frick, dude. It's playlist choice. But it's not a playlist. Do I cast it? And I want to say that works, but I'm not entirely sure. No, I never printed the button. Okay, and get layout, of course. How do I add the button? I need to add the button somewhere here. New playlist. Delete playlist. Okay, let's see what that does. Yeah, so that's not really doing what I needed to do at all. Oh, I'm not showing it. Let's just copy this right here. What kind of event is it? It's a mouse event. Now I am confused. It's a mouse event though. Unable to solve. Oh, yeah, that'd do it. Okay. It's not, it's set on action, it's set on mouse. I don't know, bro. Like, I don't mean to be that guy, but it doesn't seem like it deleted it. I don't want to be that guy, but it's just not working. Like at all. No, this function makes it impossible for me to delete the main playlist though. Oh, it's gone though. Like it worked. Now I'm a little bit confused. I'm not setting the combo box, maybe? What does this do? No, this is working, by the way. This is working and deleting it from here. But it's still in the combo box, and somehow it's still being like... My roommates are using the blender. Okay. Brother. Okay, we'll fix that later. Okay, how do you add to playlist catalog? Set playlist, delete. Maybe this should be in here. Set playlists. You know, works. I just want it to go back to the main playlist. What's the problem? Whoa. Set on action. That's just not what I wanted at all. Nice. Nice. Okay, nice. Nice. So now we need to fix deleting every single song. Let's just commit that. Honestly, that was a good feature. I kind of want to start committing like multiple times. Git commit dash. I don't know how small commits are meant to be, you know. What is, let me just print sout current index. If it even lets me, dude. Index 2 out of bounds. Oh, so it's not about deleting all of them, it's deleting the last one. Okay. That's a little odd. This is also redundant. Okay. That's it. That's all it does. So I'll be right back. Okay. So I think something's wrong with this remove one. What does it do? Remove? If the list is not, it is unchanged. Wait, what? Index 0 out of bounds for length 0. Why doesn't it go away? So hold on. So if it's highlighted, dog, what? Index 2 out of bounds for length 2. What? I wasn't paying attention. So I have this one. I'm gonna start playing it and I'm gonna delete it. Ironically, it's still playing it. And I can't. Oh my god. That's another terrible bug. But if I delete this one, that doesn't make any sense. I don't really get why. This should just trigger. I don't understand, like. String of song. Okay, 3. 3, 2, 1, 0. Why is this still here? And I can still click on it. So why is this still there though? That doesn't make sense. Okay, let me try something different. Okay. So processing. Song.getName. Okay. Yep. So if I go here, I delete this one. I delete this one. So I should only be... Dog, what? Because it's not index 0 out of bounds. It's not real. It's why is it still there? But it's only the one that has a style on it though. Like if I go here and I like set the style here and I delete this song, I just get a freaking random error. How is index 2 out of bounds? That makes no sense, bro. Am I deleting it before I'm getting the layout? Is that the problem? But that's what I'm supposed to do though. It shouldn't even exist. Like, why is it being? No, this makes no sense, bro. Because of this. I think it's because of this right here. But it should be clearing it. It should be getting it and then just clearing everything. So Wait, when I clicked it, wait. Maybe I should do this after this. Let's try that. But that wasn't. But it'll work though. What? Wait, what did I just do? And that's wrong? For what reason exactly? What? That worked exactly how I thought it would. I don't know what I changed, but... What? I probably don't even need this right here. Uh, is there like a is playing? Song. Is it like... basically what I want to do, guys, is when you click, there's only one button right here. It's pause or play. And if you click it, it changes to the other one. Like if I click play, it just changes to pause. Oh, and I have the desktop audio going, dude. Oh, I'm so screwed. I don't know how to do that. I thought I could just do media. I think I need to set this to Boolean is playing. I don't know if that's gonna work, but okay, so hold on. Now it's like if is playing, and it's like, what's wrong? Else. Bro, why not? Stupid. But it doesn't get the layout, I don't think. God damn it, bro. Oh, it's right here. Get music controls. Yeah. This might be harder to implement than I thought. Okay, we got song search, song. That's not good. Need a way to call this, dude. Oh my god, dude, why do I suck at coding? I just need this to... do I? Yeah, I need this to update this. But I need to not have all this garbage. Well, maybe I can do like... public button previous. Public button next. And then down here, it's this dot previous equals previous. This dot next equals next. It's this dot. And then fuck. Okay. Does that work? And then we do get layout, this dot previous, this dot next. Let's try that. That was fast. I'm not entirely sure why that happened, to be honest with you. Oh. Yeah, they'll do it. Yeah, they'll do it. Can this just be previous? What happens if this is just previous, like it was before? Nope. Just doesn't want to work, dude. No, the problem is not this. The problem is that I'm calling it at all right here. Yeah, the problem is I'm calling it right here, and that's why it's doing that. Hold on, I'm just confused, like, when this is even being called. Okay, so, like... Okay, song get layout. Oh, it's being updated right here. Okay. No, that doesn't make sense because this should have been, because that means that this is being called. What is it called again? Get music controls. It's being called right here. Let me just print out like one of the buttons. Maybe it's just DW. Nah, see, that would have... Oh my fucking god, dude. So why can't I just do... So why doesn't this give me the same thing? It does. I'm just a little bit confused, dog. False. False. What? Tell me it's updating something else, dude. Is it static? Public static boolean? I don't get why it's not working. False. True. Oh boy. False. Yeah. Okay. Yeah, I don't know what to do. I'm not gonna lie. I guess it's just right here, right? Is that what I'm doing? Play song? It's raining outside. I don't really get. Oh, okay. Got it. You want to update the button state. This should say pause right now. Okay. So yeah, so is the initial state wrong? What the hell? When I switch songs, it breaks. which is weird because like okay, so when I click on one, that's the problem. So playlist, mouse. You're shitting me. What? Handle mouse click. Handle song click. Try that. Nope. Current song dot reset. Oh, there it is. Okay, I'm happy with that. In fact, I'm ecstatic. What the fuck? Import class. Oh, it's not a thing. Okay. Yeah. All right, and it's exactly 3 hours. All right, that's gonna be it for me. I think this was a good place to stop. For sure, for sure. All right. Peace.